Hi everyone, I'm Ashwin and I welcome to the Cosine Similarity session using OR today. Before jumping into the code, let us see the concept of cosine similarity, how to calculate it and some applications of it. By the way, if you have missed our previous video on word cloud or tf-idf, we recommend you to watch it. You can find the link in the description. Okay now, what is cosine similarity? Cosine similarity is one of the methods that is used to measure similarity of documents or comments. Cosine similarity does this by measuring angle between two comments or documents. Like cosine similarity, we also have other measures like Euclidean distance or Jaccard to determine the similarity. While there are various measures, you may be wondering why we are discussing about cosine similarity today. We are discussing this because cosine similarity is very powerful in text analytics because we always have documents or comments with unsimilar length. So a particular word would have occurred more in document 1 than in document 2 just because document 1 is long. Say for example, if we see Amazon reviews, some would have given the review in one line, but some would have written a long paragraph. Although both reviews might convey a similar meaning, just because of the length of document, distance might be high, which may indicate dissimilarity. But cosine similarity overcomes this problem by measuring the angle between two unequal documents. So basically it distorts the magnitude. So even though one document is short and another document is long, if they are of the same theme, then it indicates a lesser angle between two of them. To get a good understanding, let us see how Euclidean distance and cosine similarity is calculated using an example. Let's move to the Excel sheet now. The first step is to calculate document term frequency matrix using tf-idf process. Here we have already calculated it. If you want to know how this is calculated, see our previous video on tf-idf which has a detailed explanation on this. We have unique terms in rows and documents in columns. You can notice that only certain words are present in rows because many of the words are stop words which are removed in data cleaning process. In the next step, we will calculate Euclidean distance. It is very simple and most of them would have practiced this in their schooling. As said before, here we are trying to see similarity between two documents. So, we will calculate Euclidean distance between two documents at a time and put the value in a matrix. Here we have document 1 to 4 in rows and document 1 to 4 in columns as well. Euclidean distance formula is very simple. It is square root of x2 minus x1 the whole square plus y2 minus the y1 the whole square and so on. So here for between document 1 and 2 it will be 0 minus 0 the whole square plus 1 minus 0 the whole square plus 0 minus 1 the whole square plus 0 minus 0 the whole square plus 0 minus 0 the whole square. So the Euclidean distance between document 1 and 2 is 1.414. Similarly, we can calculate the distance between document 1 and document 3, document 1 and document 4 and so on. Remember, the diagonal value will always be 0 as we are comparing the same document, that is document 1 and document 1, document 2 and document 2 like that. So its values will be same. Okay. So having calculated this, we will now see how cosine similarity is calculated. Like Euclidean distance, this also we have done in our schooling, probably in the chapter vector algebra. The cosine similarity is product of vector A and vector B divided by square root of vector A square multiplied by square root of vector B square. Here, if you want to calculate cosine similarity between document 1 and 2, the value is 0. Only between document 3 and document 4 we see some value. Having calculated this, the most important thing here is the interpretation. In Euclidean distance, the distance is calculated, while in cosine similarity, orientation, that is angle is calculated. We know that cos of 0 is 1, indicating the angle between two vectors or two lines is 0. So in cosine similarity, more the value, lesser the angle, indicating two documents are similar to each other. While in Euclidean distance, lesser the value, lesser the distance, indicating two documents are similar to each other. So, while interpreting the values in Euclidean distance, we should interpret lower values with more similarity, while in cosine similarity, higher values indicate more similarity. One easy way to remember this in the matrix diagonal, Euclidean distance will be 0, which indicates similarity, while in cosine similarity, it will be 1. Okay, so where document similarity measures like cosine similarity or Euclidean distance gets applied. There are a number of areas on where these gets applied. Some of the major ones are finding plagiarism between documents, mostly used by patent organizations, and also in colleges where they want to measure similarity between two assignments. If found highly similar, boom, you have high chance of getting caught. The document similarity measure is also used by search engines. You know that the primary function of search engine is to fetch most relevant results for the input query. Often we see that although input query is little bit different, the results might be same. You ever wondered how? It is because search engines like Google would have classified similarity between the input query, and if found highly similar, it fetches a result that has been already been indexed. So try typing most trending input query, say like coronavirus status. You often end up in getting a search result much faster. It is also used in industry like customer services where applications like chatbot are pretty much relevant there. Even though the input query is different, like it is semantically different from different users, it tries to fetch you similar answer. Also, sites like Quora or Stack Overflow might be using this technique to see if the question is being already asked by users so as to avoid duplicates. Okay, having gone through the concept and applications, let's quickly jump into the code. First, we'll install all necessary packages required for reading Excel, filtering, data cleaning, and calculating Euclidean distance and cosine similarity. We will now take a sample data consisting of 7 reviews of Amazon Eco product. With these 7 reviews, we are going to see which reviews are similar by Euclidean distance and cosine similarity method. At the end, you will understand why cosine similarity makes much more sense than Euclidean distance. As we are doing with tf-idf and workflow tutorial, we will convert the text into a corpus, but a collection of text, and perform data cleaning activities using the tm package commands. Post that, we lematize the data and convert the corpus into a document term matrix using tf-idf method. This is not much readable, so we convert this into a matrix and store it in m underscore tf-idf. Now coming to Euclidean distance, we have a simple command called dist in R that calculates Euclidean distance between two documents. As you can see, we have specified the method as Euclidean. We also have other methods like Jacob. In the diagonal, we have set it as true. If we set it as false, then the values will be blank in the diagonal. Also, we have set upper as true. If we set that as false, then values in the upper portion will be blank because distance between document 1 and 2 is exactly as same as distance between document 2 and document 1. For our understanding purposes, we have set both to true. At the end, we have mentioned p value as 2. So what does p denote here? P denotes the Minkowski distance, which is a metric in a normed vector space. Don't get overboard by it. It is just that how distance gets calculated. You can calculate the distance between 2 points using straight line method or any other method. If you substitute 2 in this formula, you will get the Euclidean distance formula. Now let's see cosine similarity calculation. We are calculating cosine similarity using text to vec package. Sim2 is the command, and here we are having the method as cosine indicating cosine similarity. At the end, we are having the norm as L2 indicating we are normalizing the matrix, that is converting the matrix values to unit vectors so that our only focus is on orientation, that is angle. We also have other norms like L1, but L2 is the norm that is more used in Euclidean space. Having calculated Euclidean distance and cosine similarity, let us start comparing the results to see which one makes more sense. Before that, let us convert both the things into a data frame for better readability. To see similar documents, I have written a small function that can tell you which document is similar for a particular document. In this, we used Euclidean data frame and we have sorted it in ascending order, that is descending is equal to false. We can also change the number of recommendations for a document. Here we have specified it as 2. We can change it to 1, 3, 4 or so on. We invoke the return function for document 4 and we see that nearest document as 7 for document 4. For cosine similarity, we will use the same procedure and we see nearest document is 5 for document 4. Let's try for another document, say document 6. Let's change it in Euclidean and in cosine similarity. In Euclidean, we see document 2 as nearest to document 6, while in cosine similarity, it is 7. So which makes more sense? Let us find out by seeing the comments. If we see the fourth document, we can see that document 4 and document 5 are much similar to each other, isn't it? And if you see document 6 and 7, it is much similar to document 6 than document 2. So cosine similarity gave a much higher accuracy and much better result than Euclidean distance. We can also interpret the same data using heat maps. For this, we use a package called superheat in R. First, we'll plot using Euclidean distance. If we see the heat map, we have a nice color orientation from blue to yellow. The closer the document, the more bluish it appears, and if the documents are far away, it is presented by yellow color. If we see document 4, document 7 is having a blue tinge, indicating it is much closer to document 4. Now, we'll try the same using cosine similarity data. Here also we see heat map orienting from blue to yellow, but we need to interpret the color little bit differently. As in cosine similarity, larger the value, more the similarity. So while using the heat map for cosine similarity, yellow color indicates a much closer document while blue indicates a document which are not related to each other. So for document 4, we see document 5 is having a green tinge which is farther away from blue, indicating a good relationship between document 4 and document 5. As an additional interpretation, we can use YR command inside the heat map where we can specify the document number which can calculate the distance between the specified document and other documents. For the specified document number, we'll see the value plotted at this side. So for document 4, we'll see higher value between 4 and 5 indicating a higher similarity. If you are going to use the same command for Euclidean heat map, then interpretation will be opposite, that is lower the value, higher the similarity. We have now finished the cosine similarity. If you want to try with a bigger data set, you can use the full set of Amazon reviews I am given below. You can use it, have fun for yourself, and unearth some interesting insights there. Do try it and post the insights in the comment section. I am hopeful you have understood now on what is cosine similarity, applications of it, and code base in R. For your reference, the code and dataset are uploaded in GitHub repository. Find the link in the description. If you have any feedback or queries, please feel free to post it in the comment section. We'll be more than happy to respond to you back. In our next session, we will see how document clustering, that is grouping of similar documents or comments, takes place, which is a natural progression from the similarity measure. Till then, it's bye from Simply Analytics team. Bye bye.